All right. This is Group Nine's recording. Hopefully, Brandon will be able to make it for the next one. And we're going to go over lessons 4 and 5. So, for the preparation on lesson 4, this did actually come pretty easily to me. And so it wasn't that crazy. Um, Part 2 of lesson 4. For question number 5, an 8-sided die has 8 possible outcomes for each roll. Calculate the probability of a number greater than 5. So to do that, since it's an 8-sided die and anything greater than 5, so there's 3 numbers greater than 5, 6, 7, or 8. So I did 3 divided by 8, which gave me 0.375. Number 6, calculate the probability of not getting a number greater than 5, which even just by taking I think it's rule number 3, so subtracting the previous answer, 0.375 from 1, and you get 0.625. All right, so I'm going to move to the group quiz, which is ironic because I'm not in much of a group at the moment. All right. All right, so human blood can be classified into one of our basic types, O, A, B, and AB. The portion of people in the population of the United States with each of these blood types is summarized in the following table. Question number 3, what blood types and the proportions given in the table above define a probability distribution? So we've got O, A, B, and AB, and if you total up everything, it does equal 1. So I believe that would be a probability distribution. Question number 4, what is the probability that a randomly selected person in the United States has a type O blood? And just by looking at the chart, be 0.45. Question 5, what is the probability that a randomly selected person will not have type O blood? So that would be anything other than O. So 1 minus 0.45 is 0.55. That would be everybody else other than O. All right. So next is Carolyn Wills and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle is one of the dogs that demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 did. Question number 6. If the dogs guessed at random, what is the probability they will correctly identify the dish containing the specimen from the bladder? So if there's 7 bowls, so if it was just picking one, that'd be 1 in 7. Which would be 0.1428. And if we're going to round to 3 decimal places, it would be 0.143. Question number 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, or there's little evidence that dogs can detect bladder cancer. So if it was random, if it was 1 in 7 of the 54, then he would have only gotten it right 7.5 times. So the fact that he got it right 22 times says that dogs can detect bladder cancer. M&M's. The distribution of the colors in the bag gives us the table. What is the probability of drawing a red colored candy? Table. Gives us the answer for that. 0.13. Next, it's asking for us to figure out what the chances of it being green. So all we have to do is total up everything else and deduct it from 1. So all the others total up 0.84, which means the chances of getting a green would be 0.16. Question 10. What is the probability that a randomly selected candy is not green? So we just figured that out. It would be 0.84. Because all the other ones, if green is 0.16, you're going to get anything but green, it would be 0.84. Now we're talking about ACT scores. We got our chart. Half of the observations are less than or equal to what number? that should be the median. Should be 24. Should be 50%. The top 25% of the students scored above what number? So for that, I'm looking for the Q3. So that would be 75%. So anything above 27. Which of the following statements is not one of the three rules of probability? So we've got the probability that an outcome will not occur is 1 minus the probability that it will. That is probability that a number between 0 and 1. That's true too. If the probability is high, then the probability is positive. Probability is low, then the probability is negative. That's not a rule. And the last one, the sum of the probabilities is any probability is 1. So, and we know that that is true. All right. Here's hoping I didn't flub anything up. And we got 100% on that one. All right. So I'm going to move on to lesson 5's preparation. This one was obviously a little more in depth. I did have a little confusion as I was going through it, just with my main thing was that I was rounding too early and calculating some stuff, and but in general, the z-score, once you got a hang of it, is pretty cool, and you could figure out, as long as you have most of the information, you can figure out a lot of stuff. So lesson 5, dropping down to part 2. So this one was where it started, where I was like, well, my numbers are very close, but not quite. And then I figured out that I wasn't doing the math with enough decimal places at first. So number 6B, I got 0.0533. C, that one was asking what proportion of the people who take the quantitative portion of the degree will score above 165. So once you figure out the z-score on that, then you can use that handy little applet, and you can figure it out. If a student score is the 10th percentile, what would their corresponding z-score be? So the applet, again, is what came in handy there. You just plug in 0.10, and then that gives you the z-score. So if you plug in the area, it'll give you the z-score if you got the right section. area highlighted because you're looking for 10% or less. So that would give you the z-score of negative 1.282. D, what is the quantitative GRE score for the student who scored in the 10th percentile? So with that one, because you have the z-score and you know the mean and you know the standard deviation, you can multiply the z-score by the standard deviation and then add the mean to it, and that'll give you the score of the 10th percentile, which was 139.518, but when you round it up to 140. Number 7, the mean speed of hydrogen at room temperature is 1,800 meters, meters a second, with a standard deviation of 600. So A, it tells us the mean and the standard deviation. It's right there. For B, what is the probability that a randomly selected particle has a speed over 2,500? So you just plug it in to your equation, 2,500 minus 1,800. That gives you 700. You divide it by the standard deviation of 600. Which gives you 1.1666 as a z-score. So when you plug in the z-score into the applet, you do that, and then you highlight the right area, and it gives you 0.1216, and you can round that to 0.1217 or 0.122. Just depending on how many decimal places you want to go out. All right. So 7C. So the probability that it's less. So if you just take the simple math, subtract what we just figured out from 1, it gives you 0.8783. So that one's pretty easy. D. So now we're figuring out a probability that has less than 1,500. So you just go through the same equation, 1,500 minus 1,800 will give you negative 300 divided by 600. So that gives us a z-score of negative 0.5. Plug that into the applet, and then you can select anything to the left, and that gives us .3085 area. As the answer. E, what is the probability that a random selected viral event has a speed that is between that? So you can figure out, because we've done above and below, but now it's point. The answer is 0.5698. All right, F, what is the third quartile of the speeds of hydrogen at room temperature? So if you click and you figure out what exactly at 0.75 in the applet, then that gives you 2204. 0.4 millimeters or meters a second. All right, then determining which plots. So I got plot A was not normal, plot B was not normal, C was normal, D was normal, E was not normal, and F was normal. So this one took a little more figuring out. There was times I felt like it was a little messed up because the z-score only goes 3 decimal places, yet the area goes 4 decimal places. And so when you're typing into the z-score, it'll automatically round that z-score for you. And so it throws things off just a little bit, in my opinion. So I'm not sure if there's a different way we should be doing that, but obviously we were told to use the applet, and that's what I did. So next I'm going to go to lesson 5's group quiz, and hopefully we can figure this out. I did the preparation beforehand. I am the participant in this group's meeting. Question number 3. The total area under a normal distributive curve must equal 1. Under certain circumstances, a normal distribution curve can drop below the x-axis. I believe that is false. A normal distribution curve is symmetric. Agree with that? Use the next image to answer the next 2 questions. Which of the following elements of the figure represents the z-score? So that would be C. Number 7, which of the following elements of the figure represents the probability that the z-score will be greater than 1? That would be B. Question 8. According to the 689599.7 rule, what percentage of the data from the bell-shaped distribution will be within one standard deviation of the mean? Write your answer as a percentage. So we know that the 689599.7 rule. So it's one standard deviation, two standard deviations, and three standard deviations. So the answer of one standard deviation would be 68%. Question 9. Suppose that z-scores from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1? So it's funny because that sort of directly applies to that same rule, but for giggles, plug it in. So if you plug it in and it wants super decimals, a z-score of -1 to 1, the area in between is 0.6827. So it's 0.6827. So if we're rounding to 3 decimal places, it would be 0.683. Question 10. Suppose the z-score from a standard normal distribution. What proportion of the z-scores will be between 2 and 2? All right, plug that in. So that gives us 0.9545. So since we're going to round to the third decimal place, it would be go 0.955. Question 11. Say next one. It's just asking for 3 deviations of the z-score. That's 0.9973. We would round that to just 0.997. All right, question 12. It's sort of a shocker that it pretty much matches the 68, 95, 99.7 rule. All right. Use the following information to answer the next 6 questions. I think it's going to get real, people. What proportion of the population has a protein requirement that is less than 0.60? must be consumed each day per kilogram of body weight? Mean protein requirement for adults is 0.65 grams of protein per kilogram. And the standard deviation is 0.07. So what proportion of the population have a protein requirement that is less than 0.60? So we plug that into our z-score formula. So the mean is 0.65, standard deviation 0.07. They're asking us to figure out everybody that's going to be less than 0.60. So 0.60 minus 0.65. Gives us negative 0.05. We divide that by the standard deviation, 0.07. That gives us a z-score of negative 0.7142. So plug that into the applet. That gives, with the z-score, 0.71, and it rounded it to 4. Everybody less than that, probability is 0.2376. And we're going to 3 decimal places. 0.238. All right, what proportion of the population has a protein requirement that is more than that? So since we just figured that one out, so we know that everything less is 0.238. Subtract that from 1. Give us 0.762. So that would be everybody above 0.6 grams of protein per kilogram. So next, question 15. What portion of the population have a protein requirement that is less than 0.7? So we just have to run that same old, same old. So we go 0.7 minus 0.65. Divide that by our standard deviation of 0.07. which I believe, once you start looking at it, is just the opposite spectrum. So it's the exact same. It's the exact same number on the opposite side. Just close that on accident. Hopefully it's not jacking it up. Thank goodness it just keeps track and you save everything as you go along, right? Okay. Yeah, let's see. We're looking for anybody and everything less than 0.70 with a z-score of 0.714. So everything under that would be 0.7624. So 0.762 is the answer. So find the probability that a random selected person will have a protein requirement that is between that. Okay, so look at the applet. So everything to the left is 0.762. Everything to the left of the 0.60 grams per protein people is 0.2376. So everything between should be 0.5248. Which, if we round, would be 0.525. Question 17. Find the 35th percentile for the protein requirements of adults. Let's look at this beautiful applet. 35th percentile. That, plug that in, that gives us a z-score negative 0.385. So then we can do all that beautiful math. So the mean is 0.65 over the deviation of 0.07. So we take our z-score, we multiply it by our deviation, and then we add our mean, so the 35th percentile should be consuming 0.623 grams of protein. And that is rounded to the third decimal. Ooh. Screw that up. That's for 17. Question 18, find the 80th percentile requirement, protein requirement. It's the same thing. That gives us a z-score of 0.842. We'll multiply that by our standard deviation of 0.07. And then we will add our mean, 0.65. So that would give us a 0.7089, so we'll round to 0.709. All right, here's hoping we didn't mess anything up too horribly. And we have success. 100%. Can't complain about that. I am pleased. So this is Group 9's recording for business statistics for both lessons 4 and lesson 5. My name is Ben Garbett.